Hey Internet. Well, tonight we're going to do something a little bit different. We're back here again with the Arduino Key Studio 4-wheel drive robot car version 2. And we do have the latest version of the servo software. We have written a new servo routine for it, and we've got the eyes there. You can see the eyes are kind of in a scan mode. Anyone who's ever played Grand Theft Auto, I don't know if other ones do it, but in San Andreas, if you put the controller down for a while, CJ, the player, goes into like, I call it autonomous mode, where he just kind of wanders, or not, he doesn't move, but his attention wanders, and his vision will capture things in its gaze, like passersby, accidents, cops chasing other vehicles, and it'll capture CJ's attention. And that's kind of what I've got here. And if anything catches its attention, it turns a gaze to look towards it. So this is not really what we're here today. We're looking actually at this book here. This is called How to Build a Computer-Controlled Robot by Tod Loofbourrow. This is from 1978, and I remember this book as a child. When it came out, my library actually had a copy of this book, and when I picked this copy up through eBay, I think it was, I was amazed instantly at how small it was. I remember this book being much larger. Of course, that's because my hands were much smaller at the time. I wanted to do kind of a book review on this book here and kind of give it some credit where credit's due, I think, because this is a pretty creative design and implementation for the time. Looks like something's caught his attention here. Well, let's start off by kind of looking a little bit at the table of contents. Through the construction of the basic framework and talking about the different ways to implement the power supply and the speed control, and it later on will introduce an actual microcomputer. At the time, the computer that it was using was even still pretty crude for the time. It was a 6500, I think a 6502, not even a 6510 based computer called the Kim 1. Here, this is what the robot would look like in its first stage when you develop it, and you can see that it's got descriptions of what it's going to look like throughout its evolution. There's stage 2, developing independence. You can see there the Kim 1 computer has been mounted on top of it. And the book is laid out in such a way that you can build some of it or part of it, go all the way to the end, and then even some of the more advanced features are at the end. But I assume this is the author here with his probably completed stage 3 Kim 1 based robot, which he's called Mike. I found it interesting that this book was pretty old, and it opened up to 2 sections. It opened up as someone probably had 2 sections opened on a fairly regular basis. The first one was a checklist, as I can imagine someone who's looking to build their own computer was looking at the checklist and thinking, okay, I've got to start off with stage 1. So they're always coming back to this page to decide what they're going to do for the checklist. And the other page, and we'll get to it in a moment there, that was kind of folded over, was chapter 4, page 29, because this is the chapter where the Kim 1 microcomputer is in the parts list. And even at the time, even though this was a reasonably crude computer, it didn't even have a case. When you purchased it, it didn't even have a power supply. Everything like that was BYOB. It was still a pretty expensive computer. I think even at the time, the Kim 1 was $300 or $400. And this is in the late 70s, so that was still pretty out of reach for most kids who were my age at the time, around 10 or 11. So the book is kind of laid out. You can see that it's actually talking about using basically, I think it says aluminum. Yeah, so it's not angle steel, it's angle aluminum. So he's got 20 feet of 1 by 1, 1/8 inch angle aluminum in the parts list, along with various kinds of hardware. And this is pretty easy to come by stuff. The one thing that here, you can see here the 3 motorized wheels and 1 directional control motor unit. It says see text. What it's referring to is in the back here, there's an appendix with the wheels and the part numbers and places that you could order them from if it was still 1978. I think if you ever tried to look up any of these places today, you'd probably be pretty surprised. But I'd be very surprised if they were still in business. But at least you get an idea as to where you can find the parts that are probably a little bit harder to come by than nuts, bolts, and washers. Coming back to the construction, the way that the book is laid out. Are you enjoying this? The way the book is laid out, it will actually walk you through each step of the construction fairly logically, literally down to how to cut and bolt the pieces together to make the frame, how to install the battery, and in some of the later sections, how to actually build the wiring. And what they have got you using here is perf board. What's great is that even back in the day, you get a lot of the stuff from Radio Shack, and they were kind enough, wherever applicable, to include the actual Radio Shack part numbers. So, a lot of thought went into making this book. It includes the schematic diagrams, so you're able to fairly easily reconstruct the circuits here on the perf board. And here we have some of the layout of the speed control unit. Here's some pretty beefy heat sinks in there. We're definitely looking at some old school electronics. I think if you were to recreate something like this today, you could build a lot better speed controller using digital speed controllers and brushless motors. But for the time, that was what we had. I guess I could say that that's what we had, and it worked for them. Let's move forward to some of the more interesting bits here. So what you have here is one of the motors is being set up as a steering motor, while the other 2 motors are powered motors. So we have 1 steering, 2 drive motors, and operates as a triangle, so it keeps its stability fairly well. Of course, with that battery, a 12-volt car battery on the bottom, keeps that center mass pretty low. Let's move on to some of the more interesting bits. Now that the Kim 1 computer has been installed in the robot, you can see some of the code. And the author of the book has been so kind as to include not just the actual code, but the actual flowcharts. So anyone could recreate these flowcharts in whatever programming language they wanted to. It's got a list of some of the constants here, but you can see some of the other flowcharts used for most of the programming. So all of these flowcharts here, they could be pretty easily translated into whatever programming language you want. So not only does he include all the hexadecimal values you have to input into the system, but the actual program listing in assembler. And I guess you call the 3rd row or 3rd column here pseudocode. So we're setting up some of the speed values here and some tables. And this is a 6502 assembler, loading accumulator, branching, jumping subroutines, jumping out, doing comparisons, ORing bits together. These are all pretty standard assembler commands. So these could probably be translated into just about any kind of assembly language as well. And then here we have the first of the self-driving programs. So again, he's included the full flow charts for the self-driving program and how he would want the self-driving program to control the 3 wheels, the power and the steering wheels. And it includes some pretty good instructions on how to make some makeshift impact sensors. But I also wanted to highlight the ultrasonic sensor here. Again, he's included the part numbers, the Radio Shack part numbers you would use if you wanted to get a hold of these bits. Good luck getting those today, but at the time you probably could get a hold of these. The ultrasonic sensor here basically gives it a range sensor. And he's included some examples of what he would want the range sensor program loop to do here, how you'd use the sensors to program the wheels. And then there's some other chapters a little bit later on using cameras and incorporating voice recognition systems. Here we have using some voice analysis. This is all using hardware that you would have to purchase separately. And at the time, I think the voice recognition box would probably be a little bit harder to come by. But it has an idea of how you'd program that as well. All with flowcharts and then the full program listings. So if you actually were to get a hold of all these bits, make all these sensors, acquire all the necessary parts, you could technically build your own robot and have it work exactly as he has here. When I first looked at this book when it was new as a kid, I thought this was pretty wild, and I thought, it must be harder to make a robot than this. And I think I probably ran into the same challenges as most kids who were looking at this book and thinking, oh yeah, I could do this, I can make all these. But they come to that page 29 there, right? Chem 1 microcomputer. Well, that one's a little bit harder to come by than the lock, washer, spaces, and stove bolts. So, like a lot of kids, you probably looked at this book and thought that they were going to make their own robot. They made it to page 29 and had to hold off. But today, we have robots that we can put together on our own, and maybe we can take this one apart here and make him into one of these mic robots. Oh, you don't like that idea too much. Well, we don't have to use you. Yeah, that's fine. We'll just we'll get out our old Lego. We have some Lego RCX stuff, and I think that we can probably program Lego RCX using Java, and take some of the flowcharts that are in this book here from our good friend Tod Loofbourrow, How to Build a Computer-Controlled Robot, and use some of his flowcharts to program a Lego robot. I'm pretty sure I can come up with a tripod-based Lego robot that has... Yeah, not you, don't worry. Pretty sure we could come up with a tripod-based Lego robot with one directional wheel and 2 drive motors on the other wheels. I do have an ultrasonic sensor and some impact sensors, so I'm pretty sure that I can put that together. Digging the Lego robots out of the closet might be a challenge unto itself. And we'll put this guy to sleep. You can go to sleep now. Thanks for watching, Internet.